We're solving problem 19 from the 2024 F equals MA exam. A wheel of radius r has a thin rim and 4 spokes, each of which have uniform density. The entire rim has mass m, 3 of the spokes each have mass m, and the fourth has mass 3m. The wheel is suspended on a horizontal frictionless axle passing through its center. If the wheel is slightly rotated from its equilibrium position, what is the angular frequency of small oscillations? So it's rotated, and first we want to calculate the inertia for this problem. So using the formula of inertia, the inertia at the rim, the total inertia at the rim is mr squared, mass times the radius squared. Now, we want to also find the inertia at the spokes. So if we do the normal ones, well, they're going to be 1/3 m times the length squared. And they're divided into thirds because there's 3 of them. And the fourth one is not the same m. Now, this L can be substituted into our radius because they are radii of the circle. So this is 1/3 mr squared. This last one here has a mass of 3m, so this is 1/3 times 3m times L squared. This 3 cancels out. This is mr squared. Now, we can find the total inertia inside, like on the spokes. So, there's 3 of these smaller spokes, so 3 times 1/3 mr squared, because we're accounting for each spoke. This is r squared. Now, there's just one of these big spokes, so that's just mr squared. Now, we're summing these two together, so mr squared plus mr squared is 2mr squared. Now we want to find the total inertia, and that means we have to account for the inertia on the rim. So our total inertia, total, is equal to, well, mr squared plus 2mr squared, 3 mr squared. Now, well, we have this now on our inertia, and what we really want to find is the oscillations. So, long story short, if we simplify everything, we get omega is equal to the square root of our k, kinetic energy, over inertia. And you take the square root of that. Now, we can do this a couple ways. We know that our denominator has to have a 3 in it because the coefficient of our inertia is a 3. Unless if our k is also has a coefficient of 3. But let's just not account for that. We're already down to 2 cases, A and C. And, well, now, for k, if we actually solve for k, k is equal to mg times our r over r. This is just mg. So our omega in this case would be equal to the square root of mg over 3 mr squared. These m's cancel out, and omega is equal to the square root of g over 3r squared. So basically finding our closest answer on our answer choices, we get that this is answer choice A, and that would be the answer for this problem.